In this class, we are going to discuss about the single phase fully controlled rectifier with a RL load, continuous load current with the freewheeling diode. This is nothing but a freewheeling diode which is connected across the load. The freewheeling diode goes to the on state if load is subjected to the negative voltage. So to explain the circuit operation, we have taken the input voltage VAB as well as VBA with a dotted line. The triggering voltage is applied to the T1, T2 at alpha and 2 pi plus alpha. The triggering voltage is applied to the T3, T4 at a pi plus alpha and 3 pi plus alpha. Now we are developing the output voltage waveform. We are going to start at a alpha. At alpha, T1, T2 is on, so the output voltage just follows the input voltage of a T1, T2, that is VAB voltage up to pi. After pi, the T1, T2 is forced to conduct because of this inductance. So the load is subjected to the negative voltage. So the diode is forward bias. Once the diode is forward bias, the current is transferred from the T1, T2 to DF. So at angle pi, the T1, T2 will be naturally commutated and DF will be conducting till another two devices are connecting in a circuit, nothing but a up to pi plus alpha. When the DEF is conducting, the output voltage becomes a voltage across the DF, nothing but a 0. So up to pi plus alpha, the output voltage is 0. At pi plus alpha, T3, T4 is on. Once the T3, T4 is on, the output voltage is equal to VBA voltage. So now the current is transferred from DF to T3, T4. So at pi plus alpha, DF will be off and T3, T4 will be on. Once T3, T4 is on, the output voltage is equal to VBA up to 2 pi. Again at 2 pi, load is subjected to the negative voltage, so DF is on. Once the DF is on, the output voltage is 0 up to 2 pi plus alpha. The same circuit operation will be repeating. If we draw the output current waveform, here we have taken the continuous load current. So at alpha you have to take the minimum value of current. The load is subjected to the positive voltage, so the current will be changing from minimum to the maximum value. So in this manner, pi to pi plus alpha DF is conducting, so the load current will be passing in this manner. In this interval, the current will be decreases because load is not subjected to any voltage up to pi plus alpha. At pi plus alpha, T3, T4 is on. Again, the load is subjected to the positive voltage, so the current will be increases. Again, DF is conducting decreases. If you observe here, alpha to pi, there is some amount of energy will be stored in the inductance. That energy will be only driving the diode. So diode is on. Once the diode is on, how much energy is stored in the inductance of a load? That energy will be taken by the load itself. This mode of operation is nothing but a freewheeling action. The freewheeling action will be taken place from pi to pi plus alpha, 2 pi to 2 pi plus alpha, 3 pi to 3 pi plus alpha. So in this interval, the load current also will be decreases from maximum value to the minimum value, but it should not come to the 0 because we have taken the load current as a continuous load current. If you draw the source current waveform, the T1, T2 is conducting nothing but alpha to pi. The source current becomes a positive, that is equal to the load current. So the source current is same as the load current, that is positive up to pi. From pi to pi plus alpha, DF is conducting, source is not supplying any current, so the source current becomes a 0. Again at pi plus alpha to 2 pi, the source current is equal to load current, but it is negative. Again at 2 pi to 2 pi plus alpha, DF is conducting, freewheeling diode is conducting, again the source current is 0. Here T1, T2, here T3, T4. When the freewheeling diode is conducting, source is not supplying any current, nothing but a power. To find the average output voltage 0 to pi, what is the waveform is there? the same waveform is repeating. So now the base length becomes a pi. Now I have to find out the area under this curve. 1 by pi integral alpha to pi Vm sin omega t d omega t. If we complete this integration, we are getting the Vm by pi 1 plus cos alpha. Now we are keeping this circuit operation in a tabular form. Alpha to pi, from this point to this point, the T1 T2 is conducting, the load voltage is equal to VAB. Pi to pi plus alpha, DF is conducting, the load voltage is 0. Pi plus alpha to 2 pi, T3 T4 is conducting, load voltage is VBA. And 2 pi to 2 pi plus alpha, DF is conducting, the load voltage becomes a 0. It is wrong, 0. Thank you very much for watching this video.